An exceptionally powerful bomb is ticking somewhere in the depths of space. It's going to explode. There's no doubt about that. This collision between two black holes will trigger a shockwave with the force of millions of suns. It'll rock the very fabric of our universe and sweep Earth. On the cosmic scale of things, this will happen in an instant. In this video, you're gonna find out how can we make a ticking blazar bomb of galactic proportions? Why are scientists so sure that the space catastrophe is inevitable? And when and how will the monstrous black holes blow up outer space? Astronomers have discovered this blazar bomb only recently, even though they've been looking straight at it for quite a long time. The first similar objects were found in the late 1950s and immediately baffled scientists. They're powerful radio beacons situated in places that seemingly have no stars around. Back then, these objects were called quasi-stellar radio sources, or simply put, quasars. However, researchers soon found even more bizarre space beacons, unbelievably bright quasars that showered telescopes with deadly X-rays and gamma rays. It was only in the 80s that astronomers understood they'd been looking at galactic nuclei with supermassive black holes that devour everything they can reach. The thing is, some quasars give us only a side view. That's why we can detect no more than dim radio waves coming from their heated accretion disk. At the same time, we look at other quasars as if from above, so the black hole's pole and its powerful exhaust jet emitting X-rays and gamma rays are pointed directly at us. These quasars were called blazars. If one of them erupted in the Milky Way's core, our planet would have to wave goodbye to its ozone layer at best and to all life on its surface at worst. But this particular unnamed quasar is very far. It lies 9 billion light years away from us, and during 30 years of observations, scientists never noticed it was posing any threat. Only in 2021, they finally realized that they had spent decades staring at a huge ticking bomb. What makes this blazar different from any other? Regular blazars are unstable beacons because black holes swallow the matter in unequal amounts. As a result, they flicker erratically, like a glitchy neon sign. However, the light produced by this blazar located 9 billion years away ticks every second year, as if a keeper comes and feeds it according to a particular schedule. Too bad it can't be true. In the universe, only pulsars can stick to such precise cycles, but their cycles are measured in fractions of a second. Besides, they occur because of tiny neutron stars and not supermassive black holes. As for quasars, astronomers saw one of them tick like that only once. Can you see those rhythmic flashes in the nucleus of the OJ-287 galaxy? That's a black hole with a mass of 100 million suns continually piercing the accretion disk around a monster weighing 18 billion suns. That's the cause of the powerful explosions. Although they're irregular too, sometimes flashes happen once a year, sometimes once a decade. Astronomers believe it happens this way because one black hole moves around the other along a very elongated atypical orbit. So far, that's been the only quasar pair known to science. At first, scientists thought that our blazar bomb was just another pair of that sort. But then they failed to use accretion disk explosions as an explanation for the extraordinarily punctual biennial ticking. So what's going on with this blazar after all? Astronomers went through a long list of versions and eventually came up with an even more surprising theory. Imagine that a very bright lamp is shining right in your face. Only it doesn't stay put. Instead, it moves from side to side on its stand. When the beam hits your eyes, you nearly go blind, but as the lamp turns aside, you no longer feel pain and your sight is restored. That's pretty similar to the manner of blazar flickering. But what can make a supermassive black hole with a mass of hundreds of millions of suns wander from side to side? This is something that only another supermassive black hole with a similar mass can do. What's more, it has to revolve around its blazar being 100 times closer to it than the OJ287 pair is to each other. If we place this blazar system on top of our solar system, the central blazar most likely would reach the orbit of Mars, and its partner would end up on the border of the Oort cloud, which means only 2,000 astronomical units away. If you think these two monsters have gotten way too close to each other, you aren't wrong. Scientists have calculated that they've been approaching each other for 100 million years and have already covered 99% of the way leading to the collision. Buckle up, humans. What will happen to Earth after the blazar bomb goes off? Thanks to the LIGO, a highly sensitive laser observatory, we know that a crash between black holes impacts the entire universe. In September 2015, the machine detected gravitational waves triggered by a merger of two black holes. Each of them was as heavy as 30 suns, and when they hit each other, 3 solar masses were released as part of the gravitational shock wave. It passed through Earth and all of us at the speed of light, even though we didn't feel anything. That's because the blast was weak, so space expanded and shrank on a much smaller scale than that of even atoms. This time, the collision between the black holes from the blazar bomb will generate an unprecedentedly strong shockwave. At least 10 million suns will be converted into the energy of gravitational waves. We'll have to face tears in space-time comparable to separate atoms. So, what is a shockwave like this capable of? Perhaps it could stop nuclear reactions in the sun for a moment, or break bonds between atoms and disintegrate our planet. Or maybe the whole thing will be like that tablecloth trick when you pull it out from under the dishes on a table. Will everything stay right where it was? Until now, LIGO has detected gravitational waves millions of times weaker than that, so nobody can give definite answers to these questions. Scientists are yet to calculate the exact mass of the black holes from this blazar bomb and spot the weak gravitational waves they create while approaching. Astronomers are sure of one thing: the blazar bomb will explode in just 10,000 years. Considering the lifespan of our universe, that equals something like just milliseconds on a human wristwatch. Hold on. If this blazar lies 9 billion light-years away from Earth, it means that those two black holes should have already collided, long before our solar system and home planet were born. If so, the blazar bomb's gravitational shockwave is hurtling through the Milky Way only 10,000 light-years away from us right now. Do you think we still have time to launch exploratory probes and find out what to prepare for?